Hello once again, and then welcome to another tutorial video. So in this video we'll be treating what derivative tricks. So this will be a continuation of what our previous video. Okay, so in case you watched that video, you could notice that you were introduced to several differentiation tricks. Okay, and in addition to that, we uploaded what integration tricks and all that. So this will be what like a part 2 of what that video. So in case you're new to this channel and you want to learn smart, okay, ace your calculus algebra exams, okay, all you have to do is just click on the subscribe button, turn on the post notification so that you don't miss out on future videos. Like the video, share to your friends who are also struggling when it comes to what calculus and then what algebra, so that they could also help themselves learn smart and ace their papers. So without further much ado, let's dive right into this video. So as I stated earlier, this will be a continuation of what derivative tricks, okay, or differentiation tricks. So in case you are given any question like this, okay, so x squared minus 1 all over what 2x squared plus 1 equals y, okay, so y is the function. Now this is the main formula you need, okay, in solving that problem, okay, or a similar problem, okay. This is the exact formula you'll be using. Note that in case you've already watched that video, our previous video on what derivative tricks, I stated that this has to align, okay. So it means that since we have x squared minus 1y here, the exact denominator for x squared has to be what x squared, okay. So something like x squared minus 1 all over what 2x squared plus 1. So you have what x squared beneath x squared, okay, right. That's how the format has to be. So hence the formula, okay. So we have a f of x plus b divided by what c f of x plus d. This is how the formula looks like. This is how you actually find the solution to the problem. So once you identify the what exact problem, which is in the form of quotient in this format, this is how you have to solve the problem, okay. So first you need to maintain what your denominator, which is what c of what f of x plus what d, okay, all squared, and then your numerator will be what just determinant, okay. So we know what determinants are, okay. So we have what a b c d, okay. This is your d. Now you just multiply this determinant by what the derivative of what your f of x, okay. Now let's see how we solve this problem, okay. So now after identifying that this is how the exact formula looks like, this is the exact formula you'll be using to what solve the problem. So I'll make this one green. So this is the main what formula for solving the problem, but this is the what the principle you have to employ in order to arrive at the correct answer, because once the question is not in this format, you cannot use this formula to solve what this problem. So let's look at how we solve this problem. So first you need to find out f of x. So from here our from this expression is what x squared, okay. X squared is our f of x. Let's look at our a. So a is what 1, okay. A is 1. B is what negative 1, okay. From here negative 1. Let's look at our c is what 2, and what d is 1, okay. That's from this question, okay. So first we notice that is inside. So first we notice that it's the same as what this concept, okay, or this format, and then we got to understand that this is the formula we'll be using to solve. So now we have what this lined out, okay. So all you have to do is just substitute, okay. So let's substitute that. So we have what determinant, okay. So for determinant we have what a, which is what 1, b, which is what negative 1, c, which is what 2, d, which is what 1, and then you multiply that by what the f prime of x. So f prime of x will give us what? So we have what f prime of x will definitely give us what 2x, okay. So we have what 2x. I'm trying to make this simple as possible so that in our subsequent examples I'll just go straight to the point, okay. And then we have what f of x plus d all is exponent 2. So when you solve this determinant, okay, that's 1 times 1, that will give you what 1, and then minus what 1 times 2, that will give you what minus 2, okay. And then you multiply that by what your f of x. You divide that by what 2x squared plus what 1 or what squared. So this will end up giving you, so this will be your final answer, okay. This will be your final answer for this question, right, for this exact question. So let's take another example so that you get to appreciate the concept, okay. So from here you can notice that we have another question, okay. 1 minus x squared all over what x squared plus 1. That's equal to what? Y. So from here you can notice that this expression or this question is not in this format, okay? So what do we need to do? All you have to do is just convert this question so that it will look like this format, okay? So all you have to do is just use what? Interchange the what? Their positions, okay? So we have what? 1 minus what? S squared divided by what? 1 plus what? X squared. So now we have this equation, okay, or this equation in this format, which is equal to this one. Now let's see how we solve that problem over here. Okay, we just implement this method to arrive at our answer. Okay, so we have what? The determinant. Again, you just have to find the determinant. Okay, so we have what? A, B, C. So we know that A, now A is what? -1 over here, because this is what? F of x, just from here. Okay, and then you have what? B is what? +1. C is what? C is +1 over here, and then D is also what? +1 over here. So we have what? A, which is what? -1, B is 1, C is 1, D is what? 1. Okay, and then you multiply that by what? Your f of x. Now take note, we are using what? -x squared as our f of x. Okay, so we have what? Negative what? 2x. Okay, so you divide that by what? Your denominator, which is what? 1 plus what? X squared, okay, or squared. So let's try solve this problem. So when you solve this problem, you have what? -1 minus what? 1 times 1, that will give you 1. Okay, then you multiply it. So this will give us what? Negative what? 4x divided by what? Plus what? X squared, or this will be your final answer for this question. Okay, right. So let's move on to the next trick. But before we do that, I want to give you what? A try test so that you try solving it. In case you have the correct answer, just leave them in the comment section, and then I'll try to verify whether it's right or wrong. Okay, so let's say, okay, this is a problem you have to solve. Okay, so just do your best, try solving them. Once you get the answer, just leave them in the comment section, and then I'll try to verify whether it's right or wrong. Okay, let's move on to the next trick. So for this trick, you'll be treating what? Infinite series. So in case you don't know infinite series, infinite means that it doesn't have an end. Okay, it just goes on and on and on and on. Okay, so let's say you are given what? A certain function f of x. Okay, and then that function is raised to the power another function, which is what? F of x, and that same power is also raised to the power to that another function, which is what? In order to solve this kind of problem, this is the trick you implement. So for infinite series, this is the formula you'll be implementing. Okay, so this is how the expression looks like. Y of a function of x raised to the power of another function of x, and that power is so what? Raised to another power of what? Function of x, and then it continues like that. Okay, so let's look at an example so that you get to understand what I'm trying to say. So let's say you have what? Y equals what? Okay, so we have what? Y equals cos of x exponent cos of x, and that exponent is also raised to what? Another exponent of what? Cos of x. So how do you solve this? This is the formula you'll be implementing. Okay, you might come across this problem and you might say that, how do I solve it? Okay, so once you are watching this video, you are good to go. That's why I initially stated that you have to subscribe to the channel so that whatever video we upload on this channel, you get access to them. Okay, so let's see how we solve this problem. So as the formula states, we have what? The y, okay, the x has to be equal to y squared 1 minus what? Log of y, and then you multiply that by what? F prime of x. This is your f of x. Okay, cos of x is your what? F of x. So now all you have to do is just what? Differentiate f of x. Okay, very simple. So all you have to do is just insert it into this formula. So we have what? F prime of x divided by f of x. So f prime of x is what? Negative what? Sine of x divided by what? F of x, which is cos of x. So this is how so from here the same principle implies. Okay, so just find the y, the x. Okay, as the formula imply, y squared on what? 1 minus log y. Then you multiply that by what? F prime of x, and then what? F of x. So we have what? Y squared over what? 1 minus log of y. Then you multiply that by what? F prime. So f of x is what? E exponent x. So f prime of x, okay, will be what? E exponent x. Okay, hope you know this already. So we have what? E exponent, and then you divide that by what? Your f of x, which is also what? E exponent x. So from here you could just simplify this as what? Y squared over 1 minus what? Log of y, okay, as your final answer, because this will just give you what? 1. Okay, 1 multiplying this expression will be the same as what? Y squared over what? 1 minus log of y. Okay, so whenever you are given any form of an infinite series, which is in this format, okay, so we have y of a certain function, which is the root of f of x plus another root of f of x within another root of f of x, and then it continues like that. Okay, so whenever you come across any function of this format, okay, and you are told to differentiate, this is the principle you imply. Okay, so we have this is how you differentiate this form of infinite series, okay, where you have root of a function under another root of a function and it added to another root of a function, just like that. Okay, so we have f prime of x, okay, you divide that by 2y minus 1. Okay, so this will be the formula you'll be using to solve these kind of problems. Okay, right, so that's why whenever I give you a formula, I give you a concept, I give you a formula, and then I solve problem with you so that you get to understand. Okay, so let's look at another problem under this kind of question. So let's say you are given y of f of x, where the f of x is sine of x, okay, plus the root of another sine, okay, of this format. Okay, so it just continues like that. So all you have to do is just find your dy dx, okay, which is the same as y prime. So you just use this formula. So first you need to find f of x. So f of x is most definitely sine of x. Now what is f prime of x? Okay, f prime of x means that you are just differentiating sine of x. So when you differentiate sine of x, you end up with cos of x. Okay, so all you have to do is just use this formula and then come up with your final answer. So f prime of x is cos of x. So we have cos x divided by 2y minus 1. So this will be your final answer for this kind of infinite series problem. Okay, so let's solve another problem so you get to appreciate the concept. So let's say our second example is y equals, okay, so let's say this is our y, and then we are told to find y prime. Okay, just use the same principle. Okay, you find your f of x, which is cos 2x, and then you find f prime of x, okay, which is so when we differentiate cos 2x, we end up with minus 2 sine of 2x. Okay, in case you know how to differentiate trig functions, okay, this is what you end up with. Okay, so let's proceed from here. So per the formula, okay, you have f prime of x divided by 2y minus 1. So we have f prime of x, which is minus 2 sine of 2x, and then you divide that by 2y minus 1. Okay, so this will be your final answer for this problem. Again, you could try your hands on this problem. Okay, so let's say y equals let's say log of x plus the root of, okay, let me just make it simple. Okay, log of x. Okay, and then let's say the fourth one is let's say y equals the root of maybe tan of x plus the root of tan of x. Okay, so try solve these two problems and then let's know the answer you get in the comment section. Okay, I'll try verify whether it's right or wrong. Okay, so let's proceed to the next form of infinite series or another derivative tricks. Okay, so whenever you come across any derivative and it's of this form, okay, maybe you have a function of f of x, okay, and then raised to the power a function of g of x. Okay, whenever you come across any differential and then it's in this format, so simply put, we have maybe d of the x, and then we have f of x, okay, exponent g of x. So whenever you come across these kind of problems, this is how you solve the problem. Okay, so this is how you solve your or you find dy dx or y prime. Okay, provided it's in this format. Okay, so this is how you solve it. So first you just keep the expression, which is f of x, and then the exponent g of x. Okay, and then you just open your bracket. Okay, so whenever you come across any function of this form, okay, and then you have maybe a function of y with f of x exponent g of x, okay, or in this format, okay, this is the formula you'll be using. Okay, keep the formula in mind. It might look lengthy or long, but it's very simple. Once you understand and solve problems, you are good to go, okay? So we have y prime of what? F of x, and then what? Exponent g of x. Then you open your bracket, you have g of x on what? F of x plus f prime of x plus log of f of x multiplying g of x, okay? So let's take an example so that you get to understand or appreciate the concept. Alright, so we have what? Our question. So from here we have what? X exponent sine of x. So from here we could just notice that f of x is what? X, and then what? G of x is what? Sine of what? X, okay? So let's try put it in this formula, okay? Let's try put it in this formula. Don't look at the formulas too lengthy, but try to understand the formula, okay? It's very simple. So let's see how we do that. So y prime is equal to what? F of x, which is what? X exponent what? G of x, which is what? Sine of x. Okay, now let's look at what's in the brackets. Okay, so we have what? G of x, which is what? Sine of x, okay? Sine of x divided by what? F of x, which is what? Only x, okay? Okay, so you multiply that to what? F prime of x. So now, when you differentiate x, you end up with what? 1, okay? Then we have plus what? Log of f of x. So we have what? Log of what? F of x, which is what? X, okay? Multiplying g of x, which is what? Sine of what? X, okay? From here, you are just done, okay? This is the entire what? Solution. So that's why I initially stated that all you have to do is just know how to memorize the formula or know how to understand the formula, and then you'll be able to solve the problem. Very simple, very straightforward. So let's look at another example. So this is the second what? Problem. So we have y equals what? Sine of x, s cos of x, okay? So the same principle over here. This is the same principle we'll be using. So we know our what? F of x to be what? Sine x, and then what? G of x, okay, to be what? Cos x, okay? So let's use the same principle. So we have what? Y prime equals what? We rewrite this formula out, okay? So we have what? Sine of x, okay? Sine of x exponent cos of x, and then we write or we bring our big bracket. So now we have what? G of x, okay? So we have what? Cos x divided by what? F of x, which is what? Sine of what? X. After that, we just what? Differentiate, okay? So from here, we differentiate f of x, which is what? Sine of x, okay? So when you differentiate sine, you end up with what? Cos of x, okay? After that, you just add your what? Log of the two functions, okay? So we have log plus log of the two functions. So we have what? Sine of x, okay? Multiplying what? Cos of x, okay? Right, so after doing this, you are done. This will be your final answer for this problem, okay? This will be your final answer for this problem. So this, take this as a take home what? Problem, okay? So let's say you have maybe y is equal to what? Let's say you have cos of what? 2x exponent what? Tan of x, okay? Just use this problem as a try work, and then let's know the answer you get in the comment section, okay? So let's move on to the last and final what? Principle, okay? Okay, so for this concept, okay, so let's say you are given what? Y, okay? Y equals a certain expression. So it looks like what we've recently treated, but it's a bit different, okay? So let's say you have y equals what? Maybe z exponent x, okay? Z exponent x. So the z stands alone, x also stands alone. There are two different what? Expressions, okay? So whenever you come across any form of this problem, this is how you solve it. So the y prime, so from here you can notice that this formula looks similar to what we initially used, okay, to find what similar form of what? Differential problem, but this is quite different. So let me show you how these examples looks like, okay? So for these ones, this is how the examples look like. So we have maybe y equals what? Okay, this is how these examples look like, okay? So this could be what? Something like an addition. So from the first example, you can notice that they were just single expressions, okay? Or single trig functions or single expressions being written down, okay? With their respective exponents, and then you are told to what? Differentiate, okay? And then we used this formula, okay? Right, so, but this one is quite different, okay? This one is quite different. For this expression, you'll be told to what? Add, okay? Add two expressions. So I want to use this first example to help you understand the concept before I try adding, okay, before I try introducing the addition and what subtraction and all that. So pay close attention because this is the final example, and then I always save the best for the last, okay. They are always a bit complicated, that's why I save them for the last. Now let's see how we do this. So from here, from this expression or from this formula, you could notice that we have our z and x. So z, from here, z is what? Cos x, okay, and your x, okay, is what? 2x. So I could either use a different what notation for this. So let's say let's see, what should we use? Let's say we have what? It could be anything. Let's say this are f, okay, so these are f. So we will change everything from here. So this will be what? F. This will be f. This f is too long, okay. This will also be f, so that we don't get confused when it comes to these what expressions, okay. So this will also be changed to what? F. This will also be f. So it means that this x will now be what? F, okay, so that you don't get confused, okay. Right, so now cos x is our z and then 2x is our what? F. So just look at the formula. We are told to what? Differentiate. So this is what you do. We have what? X, z, okay. So just write z out, which is cos of x, and then raise that to the power of what? The f, okay. Right, so we have what? 2x. So you can notice that it's similar to what we initially solved, okay. So but a bit different. So from here you just open your bracket again. You have your f, which is what? 2x divided by what? Your z, which is what? Cos of x. So again you can notice that it's quite similar, but let's proceed and see how things change from here. So we have z prime. So from here it means that you have to what? Take the z prime. So when you differentiate cos of x, you end up with what? Negative what? Sine of x, okay. And then you add that what? The differential of f prime. So when you differentiate 2x, you end up with what? 2. And then you have what? Log of what? Z. Z is what? Cos of x. So you have what? Cos of x, okay. So this will be your final answer for this problem. Very, very simple and straightforward, okay. You could try simplifying what's in the bracket. It doesn't matter. That's the most important thing we want to know, okay. We want to arrive at the right answer, and it seems we've gotten it, okay. That's why initially I stated that this is quite different from what we initially treated, okay. This problem is quite different from this one, okay. This is quite different from this one. You could notice that we had what? Log of f of x multiplying what? G of x. But this is quite different, okay. For here we had what? F prime log of z, okay. Right. So let's take another example, okay. That's why initially I stated that you'll be adding. So let's see how you add, okay, for the second example. So let's say example 2, we have what? Okay, so let's say we are told to what? Solve this problem, okay. So we'll be using the same principle, okay. Using the same principle, same formula, okay. So we have to identify our what? Z and f. So from here we have what? Z. So we have 2 z's and 2 f's, okay. That's why initially I stated that you'll be adding. So this is just one, okay, one of these, and then there's another one. So we have 2 z's and 2 f's, okay. So we have z1. So let's say z1 is sine of x, okay. z2 is what? Cos of x, okay. This one and then this one, and then we have what? Okay, right. So this is how we solve this problem. So let me, because this is going to be very long. Okay, so we have what? Again, from the formula, you just have to, use this formula, okay, z exponent f, and then you proceed from there. Okay, so let's see how we do that. So let's start from this first one. So we have what? Sine of what? X, okay, sine of x exponent x squared, and then we have what? Our brackets. So from the brackets, we have what? F on z, okay, and then z prime plus f prime log of z, okay. So let's do that. So f, okay, so we have our f1, which is what? X squared on what? Z, which is what? Sine of x. You multiply that by what? Your z prime, okay, just from here, okay, your z prime. Now z prime, so when you take the differential of sine of x, you end up with what? Cos of x. You add that to what? From here, f prime log of z, okay. So we have what? F prime. So we have f prime. F is what? X squared. So we have what? 2x, and then log of z, and then we have z is what? Sine of x, okay. Sine of x. So we are done with this one, okay? We are done with this first expression. So let's find the second one. So plus z2, which is what? X exponent what? 4x cubed. So we have 4s cubed. Then you open your bracket. F, okay, f2. So we have what? 4x cubed divided by what? Z2, which is what? Cos x. And then you just multiply that by what? Again, from here you can notice that we took the what? Differential of sine x, that's z. Okay, so the same thing over here, you just take the what? The differential of cos x, just like here, okay? Just like the formula z prime, okay? In case you don't remember anything, just refer to the formula and then you'll be good to go. Cos x will give us what? When you differentiate cos x, you end up with what? Negative sine of x plus what? F prime. So f prime is what? 12x squared, and then we have what? Log of what? Cos x, which is what? Z from here, okay? F prime and then log of z, okay? So that is what? Cos of x, okay? And then from here, you are done. By just doing this, you are done, okay? This is quite simple. Once you follow the video step by step, you'll be able to understand all the concepts in this what tutorial video, okay? In case you don't understand anything, just leave a question in the comment section, and then in case you get confused whilst watching the video, just go back, okay, and then rewatch the video, and then you get to understand. Now this is your take home what assignment. So let's say you have y equals, okay, so this will be your take home assignment, okay? So try solve this problem, and then let's know whether you were able to arrive at the right answer. In case you didn't, we'll just guide you with what the answer. Again, if in case you want to see more of this video help you ace your calculus, algebra and all that, make sure to subscribe to the channel so that you get every video we upload on this channel. Like the video, share, and in case you have any questions, okay, leave them in the comment section, then we'll reply to them as soon as possible. Remember, learn smart, and I'll see you in the next video.